Alright, in this video we're going to be looking at doing a little bit of graphing of the cosecant and the secant function along with some transformations. And this is going to be handled in a similar way that we graph the sine and the cosine. So you might want to look at that video if you're not familiar with kind of the process. And so, like we did with the sine and the cosine, we're going to base them off of the table using the pole angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the sine is going to be your y coordinates at each one of those points on the unit circle. So that's going to be 0, 1, 0, minus 1, and 0. Okay? And the cosecant is going to be those reciprocals, okay? And I'll go into a little bit more of an explanation with the graphs here, but the cosecant is the reciprocal, so we can kind of think of the reciprocal of 0 as a vertical asymptote. Okay, reciprocal of 1 is 1, and then again reciprocal of 0 is a vertical asymptote. Reciprocal of minus 1 is minus 1, and the reciprocal of another 0 is a vertical asymptote. So what we're going to do here is we're going to go ahead and graph the sine first. Okay, so like we did in the previous video, we're going to graph the sine. Okay, so there is your sine graph. Okay, and so my motivation for having vertical asymptotes is you notice that the sine value is getting very, very small there. So the secant is the reciprocal, the cosecant is the reciprocal. So if you have 1 divided by a very small positive, that's going to be a very big number. And so that's going to give us an asymptote, and you'll have this point right here because you have 1, 1, and then it's going to be exploding up this way. Okay. Now you got a vertical asymptote happening here. On the left-hand side, it's going to be 1 over a small positive, and on the right, it's going to be 1 over a small negative, and so that'd be a large negative. So we'll have another vertical asymptote here, and so that'll allow this part to go up here, and then we'll also have the rest of the graph like this. Okay, so let's remove all that, and then I'll draw it a little bit nicer here. Okay, all right. So let's put in those asymptotes. Okay, so asymptote, asymptote, and asymptote. All right, and then we have the point 1, 1, and then we have kind of like it's sort of like a parabola-shaped type of thing that's going to fit between those two asymptotes. Okay, and then we also have the similar characteristic at 3 pi over 2 and minus 1, and then it will also be down. So again, right here and right here, you're going to have a small negative. So 1 divided by a small negative is going to be a large negative in terms of absolute value, I guess you can say, or a very negative number, and so that tells us we're going to be going down like that. Okay, and we're going to use a similar argument when we graph the cosine and its reciprocal, the secant. Okay, so we'll extend our table out. Here's the cosine values and the secant values. Okay, so cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is going to be 1. And then we'll go ahead and take the reciprocal. So reciprocal of 1 is 1. Reciprocal of 0, we can think of that as our vertical asymptote in this context. Okay. Reciprocal of minus 1 is minus 1. Reciprocal of 0, again, in this context, we can think of as our vertical asymptote. And then finally, the reciprocal of 1 is 1. And like before, we'll go ahead and draw in the cosine. So we'll draw in the cosine. And so there's our cosine graph. And like the sine, the zeros of the sine and the cosine are going to be where the vertical asymptotes of the cosecant and the secant are going to be. Okay, so there we are. And then we have the points 0, 1, and we'll approach our asymptote. And then we have pi and minus 1, and approach our asymptotes. and then we have the point 2 pi and 1, and approach our asymptote. Okay, so this might look a little bit different than what you have going on in your textbook. So it is a full period of the cosine, and so we do it this way, so it's kind of the same method for graphing all of them. So had I extended this out further and I did negative pi over 2, that would be another vertical asymptote, and if you wanted another full parabola kind of thing, you can do that, and you can do that on the other side over here as well. Because they're both based off of the cosine and sine, they're the reciprocals. Their period is also going to be 2 pi, and so all the characters that we had, or all the letters that we had in the previous video, they're going to do relatively the same thing. We have a different table to roll with, so different table for the cosecant and the secant here. Okay. All right, so we're going to graph. We're going to call it k of x, so minus 3 cosecant pi times x minus 1. Okay, and so we'll identify the same things. Amplitude is going to be the absolute value of the a. The a is negative 3, so amplitude is 3. Your k is going to be pi, and then your phase shift is going to be to the right 1. So we're going to go right 1. We'll go ahead and generate our table for sine and cosecant. So again, I'm trying to base everything off of that sine and cosine chart that we had in the previous video. Okay, so that's how I can generate the cosecant fairly quickly. Okay, now we can start generating the table for our specific transformation here, and it's going to start at 1. And that's going to be our vertical asymptote. So again, it's going to be rigged to output these values. If it's a vertical asymptote, multiplying it by negative 3 doesn't change the fact that it's undefined at that particular location. However, we'll be able to multiply the 1 and the negative 1 there by the negative 3. So we'll get some values there. Okay, so we need to know what the k is, which we know is pi, I'm sorry. So we need to know the period, so that's going to be 2 pi over pi, which is 2. So this pi is going to accelerate, so it takes less than 2 pi to complete a full period. And then our increase pi is going to be pi over 2 times 1 over pi, so that's going to be 1/2. And so we're going to add 1/2 until we get a total of 5 points for the x. So 3/2, and then we'll take this y value and multiply it by negative 3, and we get the negative 3 there. Add 1/2, and we'll get 4 over 2, which is 2. And then that's going to be this vertical asymptote here. Okay, add another 1/2, and we'll get 5 over 2. And then take that y value of negative 1, multiply it by negative 3, we get 3. And then finally add one more 1/2, and we get 6 over 2, which is 3, and that's our vertical asymptote. Okay, now like in the previous video, you can take each one of these x values and plug them in here, and that will give you these angles here. So it's been specifically rigged to do this nicely for us. Okay, so in the previous video, we painstakingly went through, I think, 2 examples of showing that was in fact the case here. So here we're going to forego doing that extra computation. Oops. I didn't want to delete the last one. What was the last one there? 3 and vertical asymptote. Okay, sorry about that. Okay, so we got all our points. We got, well, they're not necessarily points anymore. It's 5 things. Things being vertical asymptotes or points. So we got our 5 things that we want. Okay, so we'll go ahead and put all that in. Install our asymptotes. So we got 3 of them. Okay. All right, so we got 3 over 2 and negative 3. Okay, and earlier in our class we talked about the range, and so we're not going to be going up this way. We're going to stick down down where we are here. Okay, and then at 5 pi over 2, we're going to be up at 3, and there we are. So that's graphing a cosecant. And generally, we're not going to cross that x-axis, there might be some sort of horizontal, not a horizontal, but there might be some sort of vertical shift that would do that, but most likely we're not going to run into anything like that in our class. All right, let's do one more. We've done a cosecant. We'll do a secant. They're very similar. Okay, so we're going to go ahead and graph 2 secant of, what is that? 1/3 x plus 3 pi. All right, and amplitude is going to be 2. Your k is going to be 1/3, and your phase shift is going to be to the left 3 pi. Okay, and then we'll go ahead and generate that same table for cosine and the secant. And then we're going to base our transformation. We'll do our transformations off of that. Okay, so we'll start up our table at minus 3 pi. Okay, and then we'll figure out what our period is. And notice I've already figured out what this value is. I take this y value and multiply it by 2. If I had some sort of vertical shift, I would add or subtract that also. Okay, so we got our first value on our table is negative 3 pi over 2 and 2. And what's our period? Period is going to be 2 pi over k. And so that's going to be 6 pi, so that a factor of 1/3 is going to slow this thing down. So normally it takes 2 pi, now it's going to take 6 pi, so it makes it 3 times as slow. And we're going to increase by, normally we increase by pi over 2, and to offset that factor of k, we're going to divide by k, so times 1 over 1/3, and so we're going to increase by 3 pi over 2. Okay, and for the sake of the arithmetic, okay, so negative 6 pi over 2, and then if we add 3 pi over 2, that's going to give us a negative 3 pi over 2. Okay, and then that's going to be a vertical asymptote. Add another 3 pi over 2, and we get 0 as the x, and then take your y value and multiply it by 2. So we get negative 2. All right, add 3 pi over 2, and we get 3 pi over 2. And then that's going to be a vertical asymptote. And then finally add one more 3 pi over 2, and that's going to be 6 pi over 2, or 3 pi. And then multiply that y value by 2, and we get 2 there. Okay, so distance from negative 3 pi to negative 3 pi to 3 pi is going to be that period of 6 pi. So we got everything we need. So there's a negative 3 pi over 2, negative 3 pi, 3 pi over 2, and 3 pi. And we need to go up to 2 and down to minus 2. Install our vertical asymptotes. And we got the point negative 3 pi over 2 and 2, and so we're going to curve up. If you want to install another asymptote, you need to go another negative 3 pi over, or you go to the left 3 pi over 2, so you'd subtract 3 pi over 2 if you want to get the rest of that. You don't have to. We're graphing only one period. We got the point 0, negative 2, so we will have that part of the graph there. And finally we have 3 pi and 2. And so you can think of combining these two as getting that top branch of the parabola there. Okay, so that is in fact one full period of this particular graph. In the similar fashion that we did in the previous video, we've adapted it here. We will also do something very similar with the tangent and cotangent, but the period will be pi, and the increase by will be pi over 4 as opposed to pi over 2, and the process will be very similar. But that's for another video. That's it for today.